Hello again. This is section 5.5, inverse trig functions and their graphs. So in this section, we're going to do a little bit of the same stuff that we did back in chapter 6, where we start looking at inverse trig functions, their domains, their ranges, how we actually calculate them. But I'm also going to point out what the graphs of these inverse trig functions have to look like so that they're actually functions now. Okay, so that's the one key difference between what we did in chapter 6 and what we're doing here. But the calculations themselves will still be exactly the same. All right, so here we go. So the inverse sine function, again, we write that as sine with a little -1 up in the exponent. Okay, the domain of that's going to be from -1 to 1. And remember our range, the values we get out of an inverse sine are always going to be somewhere between -pi/2 and pi/2, somewhere in the fourth quadrant or the first quadrant. And so again, all of that stuff is exactly the same as what we talked about back in chapter 6. Now we can also call this the arc sine, right? So you can see it written those two ways. And then our cancellation properties, if we take the sine of the inverse sine of x or the inverse sine of the sine of x, we're going to get x. Those two things are going to cancel out as long as our domains are appropriate. Okay, so we just have to make sure that we have values that actually work within the function itself. And so that's what they're telling you there, from -1 to 1 for the original one, and then -pi/2 to pi/2 for that bottom one. Again, all of this information exactly the same as the stuff we did in chapter 6 with inverse trig functions. So just keep in mind, you're always going to get values somewhere between -pi/2 and pi/2 if you're taking an inverse sine. Now, here's the graph of sine, and then why we have to use this piece of it for inverse sine. So notice here, we know that the sine graph looks like what we have here. It goes through 0, 0, has a period of 2 pi. The problem is, if we were to take the entire function and try to take its inverse, we would be switching x and y values, and then we would end up with two values that are the same x value. Okay, so if you were to switch x and y here, it doesn't pass the horizontal line test, which means the inverse would not pass the vertical line test, and therefore it wouldn't be a function. So what we have to do is we restrict our domain now to go from -pi/2 to +pi/2. That way, from there to there, passes that horizontal line test, so that when I take the inverse, it passes the vertical line test, and I actually have an inverse function. Okay, so that's all we're really doing here. It's the only new thing, but that kind of shows you why our range values for the inverse have to be between -pi/2 and pi/2, and our domain has to be between -1 and 1, is so that that function is actually a function now. All right, so let's see if we can find each of these values. So our inverse sine of 1/2. So again, keep in mind what we're looking for is what number has a sine value of 1/2, and we can use our unit circle for that. So I'm going to think about my unit circle. Now we know in this case we have a positive value. Well, between -pi/2 and +pi/2, the only place we'd have a positive value for sine would be in the first quadrant. And we need that value to be 1/2. And remember, with sine, we're dealing with the y value. So this is going to be the ordered pair, square root of 3/2, 1/2. Well, the point where that happens is pi/6. And so our inverse sine of 1/2 is going to be pi/6. So again, same types of calculations we did back in chapter 6, but now we have our unit circle to kind of help us out to think about, okay, where's the sine value 1/2? That means where's the y value 1/2? And the only place that that's going to happen between -pi/2 and pi/2 is at pi/6. All right, now the next one says we want an inverse sine of -1/2. So again, I'm going to think about my unit circle. I need to be between -pi/2, +pi/2. Now, in this case, the only place we're going to have a sine value that's negative would be in the fourth quadrant. And so this is going to have the ordered pair square root of 3/2, -1/2. Again, we're looking at that y value. And so in this case, our value is going to be -pi/6. Again, we do need to write our answer as negative pi over 6, even though that would be equivalent to 11 pi over 6, right? If you went all the way around the unit circle there, we always want to make sure our value is somewhere between negative pi over 2 and pi over 2, so we have to use the negative value here. All right, and then this last one, inverse sine of 3 halves. Well, I know for sure on the unit circle, I don't have anywhere where sine is equal to 3 halves, right? That doesn't exist. Keep in mind here that our values inside the inverse sine have to be somewhere between -1 and +1. Okay, those are the only values we can put into the inverse sine. Well, 3 halves is like 1.5. That's bigger than 1. So this one right here does not exist. Okay, so our domain, is the 3 halves is outside of that domain, and so we get a does not exist for this inverse. All right, now we want to find approximate values for each one of these. Okay, so again, they're giving us decimals. We're going to have to use a calculator because these aren't values that are on our unit circle. So we're going to do inverse sine 0.82. Make sure when you do this that your calculator is in radian mode. And I'm going to round these to 4 decimal places. And so if we do this, we should get 0.9614. And the same thing with the second one here, 1/3, not a special value from our unit circle. And so we're just going to have to do inverse sine 1/3 in our calculator. Again, I'm going to round this to 4 decimal places. So we get 0.3398. And again, just always pay attention. If they tell you specifically they want the answer in degrees, then you can put your answer in degrees. Otherwise, we can assume here they're going to want a radian measure. All right, so now we can start thinking about our cancellation properties. So we've got the inverse sine of the sine of pi over 3. Now remember, the one thing we have to remember with these cancellation properties are those restrictions on the domain. And so if we're doing an inverse sine of a sine, we just have to make sure that our angle is somewhere between negative pi over 2 and positive pi over 2. Well, in this case, pi over 3 is between those two values, so we are allowed to use our cancellation property, and so this answer should just be pi over 3. Now, the one at the bottom here, we've got the inverse sine of the sine of 2 pi over 3. So again, as long as the angle is between negative pi over 2 and pi over 2, we can cancel and get the angle. However, 2 pi over 3 is bigger than pi over 2, right? 2 pi over 3 is going to be in our second quadrant, so it's outside of the first and fourth quadrants here. So what we have to do is actually evaluate this like we would anything else. So the first thing I'm going to do, I'm going to think, what is the sine of 2 pi over 3? So I'm going to go to my unit circle. 2 pi over 3, it's going to be right up here. I need to think about my ordered pair there. So remember, the x value in this case is going to be a negative 1/2. Y value should be positive, so square root of 3 over 2. For sine, we're looking at the y value. So that's going to give us square root of 3 over 2. So we're looking at inverse sine of square root of 3 over 2. And now we're going to do this the same way we did that first example. We need to think about somewhere between negative pi over 2 and positive pi over 2. Where is the sine value square root of 3 over 2? Well, it's going to be in the first quadrant since it's a positive value. This ordered pair here is positive 1/2, positive square root of 3 over 2. There you go. And so this is going to have a value of pi over 3. And so our inverse this time is going to be pi over 3. So again, the point of this example is just to show you, only use your cancellation property if the value is already between negative pi over 2 and pi over 2. If it's not, then you're actually going to have to evaluate what's the sign of that angle, and then think about the inverse so that we get something that's between negative pi over 2 and pi over 2 now. All right, now inverse cosine, again, all of this information, same stuff we saw back in chapter 6. Domain is between -1 and 1. Range, remember, it's going to be somewhere in the first or the second quadrant, somewhere between 0 and pi. So for our cancellation properties now, as long as our x value is between -1 and 1, the cosine of the inverse cosine of x should be x. And then if we do the inverse cosine of the cosine of x, we have to have a value somewhere between 0 and pi this time. Again, another name for our inverse is the arc cosine, right? So you might see it written that way. So either of those notations mean the same thing. And again, here's the reason why we have to restrict our cosine, our arc cosine, the way we do, is because if we restrict now from 0 to pi, you can see over here, that's going to pass our horizontal line test. Therefore, the inverse would exist and be a function because it would then pass the vertical line test. And so that's why we restrict ourselves between 0 and pi whenever we're dealing with arc cosine. All right, so let's see if we can find the arc cosine square root of 3 over 2. So again, we're going to use our unit circle. In this case, we need to be somewhere between 0 and pi. Now, because we're dealing with a cosine and we have a positive value, that tells me we have to be in the first quadrant. I need my x value this time to be square root of 3 over 2. So that's going to give us this point right here, square root of 3 over 2, 1/2. And remember, that point is at pi over 6. So our inverse cosine of square root of 3 over 2 should be pi over 6. Now the next one, we've got inverse cosine of 0. Again, we need something between 0 and pi. We're looking at cosine, so we're looking at the x value. So we need to think about where would the x value be 0. So that's going to be right up here. So this point, 0, 1. There's our x value of 0. And remember, this is at pi over 2. So inverse cosine of 0 should be pi over 2. And then finally, the inverse cosine of -1/2. Again, think about your unit circle. We need to be somewhere between 0 and pi. This time, we need a cosine value of -1/2, meaning we need the x value to be negative. That's going to put us in the second quadrant this time. So that's going to put us right up here. That ordered pair is -1/2 square root of 3 over 2. And that point is 2 pi over 3. So our inverse cosine of -1/2 should be 2 pi over 3. Okay, so let's take a look at some of our cancellation properties now. So the first one here, we've got inverse cosine of the cosine of 2 pi over 3. Again, remember with cosine, we need to make sure that our our x value is somewhere between 0 and pi. As long as it is, then we can use our cancellation property. Well, 2 pi over 3 is between 0 and pi, right? 2 pi over 3 is less than pi, so we're allowed to use our cancellation properties this time. So we should just get 2 pi over 3. Now the second one, 5 pi over 3, is bigger than pi, so it's outside of that domain. We cannot use our cancellation properties, so we're actually going to have to evaluate this step by step. Again, think about your unit circle. We got to think about 5 pi over 3. Well, 5 pi over 3 is going to be right down here. Its ordered pair then is going to be a positive 1/2 and a negative square root of 3 over 2. Now, since we're doing cosine of 5 pi over 3, we're looking at our x value. And so this means we're taking the inverse cosine of 1/2. So now I need to find the value where the cosine would be 1/2. Has to be somewhere between 0 and pi. Since it's a positive 1/2, that puts me in the first quadrant. So it's going to be 1/2 square root of 3 over 2. And that point should be pi over 3. So again, if you have a value that's outside of that domain, in this case for inverse cosine from 0 to pi, then we can't use our cancellation properties, actually evaluate the cosine at that value, and then use that to find the inverse. All right, and then finally our inverse tangent function. Domain here is all real numbers. Okay, so we can put anything we want into an inverse tangent function. The range, though, similar to sine, arc sine, sorry, is going to be between negative pi over 2 and pi over 2. Now our cancellation properties here, the tangent of the inverse tangent of x is equal to x for all real numbers, right? Because that was our domain there. But if we take the inverse tangent of the tangent of x, we have to be somewhere between negative pi over 2 and positive pi over 2. And again, just to give you a visual of why we restrict ourselves for tangent this way, if we did not, right, this original function would not pass the horizontal line test. But if we restrict ourselves between those two asymptotes at negative pi over 2 and positive pi over 2, now we're good. I can take the inverse, and it's going to pass the vertical line test. All right, so let's see if we can find each of these values now. So we want the inverse tangent of 1. Now remember, with tangent, we're looking at the y value over the x value. So we've got to think about, on our unit circle, if I were to divide the y value by the x value, where would that be equal to 1? Well, the only way to get 1 when you divide is for the two values to be the same. So I'm thinking about, where do I have a value where a point where the x and the y values are exactly the same? And I have to be somewhere between negative pi over 2 and positive pi over 2 for inverse tangent. The only place that tangent is going to be positive here, and it's going to have a value of 1, it's going to be in the first quadrant, where the x value is square root of 2 over 2, and the y value is also square root of 2 over 2. And that point is pi over 4. So again, we can't just look at a single value, either x or y, like we could for inverse sine and inverse cosine. We have to think about the division of y over x. In this case, though, when you do that, square root of 2 over 2 divided by square root of 2 over 2 gives us square root of 2 over 2 times 2 over the square root of 2. Both the 2's and the square roots of 2 cancel out, and that's what gives us our 1 here. All right, now the next one, we want the inverse tangent of square root of 3. Again, I need to be somewhere between negative pi over 2, positive pi over 2. Since we have a positive value, we know that's going to be somewhere in the first quadrant. Now, here's the trick. We've got to figure out where are we going to get a positive square root of 3. Well, there's two possibilities of where that could happen. We could be up here. This point would be 1/2 square root of 3 over 2. We could also be down here where it's square root of 3 over 2, 1/2. Okay, so we've got to figure out when we divide the y value by the x value, which one of those actually gives us square root of 3. Okay, so that's the only thing. They both have a square root of 3 in them. It's possible, right, depending on the way you divide, right, you could get one of them to work. So we got to figure out which one it's going to be. I'm going to start with that top one, and I'm going to say, well, if we take the y value, square root of 3 over 2, and divide it by 1/2, that would be square root of 3 over 2 times 2 over 1. My 2's here cancel out. I end up with square root of 3 over 1, and that is square root of 3. So that tells me it's going to be that top point. Well, that one is pi over 3, and so my answer here is going to be pi over 3. So again, because tangent is going to be a y value over an x value, think about both places where there is a square root of 3 somewhere in the ordered pair. Do your division. If it doesn't seem to work out, right, if when I divided that I got something other than square root of 3, that tells me it's probably going to be the other point. Divide those instead, and that should give us the correct answer. And then finally, inverse tangent of 20. This is not a value from the unit circle, but inverse tangent, remember, has a domain of all real numbers, so we can calculate this. We just have to use our calculator for it. So we're going to do inverse tangent of 20 in our calculator. I'm going to round this to 4 decimal places. So we get 1.5208. And then the final thing in this section, we're not going to do any work with the inverse, secant, cosecant, and cotangent functions, but just so you can see visually what they look like, right? Here are the graphs of those, right? And why we restrict their domains the way we do, so that we actually do get functions when we take the inverse. Okay, so again, no examples for this, but just so you can see visually what those inverses would look like. And again, I'll never ask you to actually graph these functions either. All right, so that's all we've got for chapter 5. Again, if you have any questions, please let me know as you're working on that homework. Come see me during student hours if you need to. I will see you next time.